Alright, let's review some trig here. So this is going to be a little different way than you were probably taught before, but I think this will be helpful. So I'm going to start by making a graph, and I'm going to label 4 tick marks going in each direction. The first one is a half, the second one is square root of 2 over 2, square root of 3 over 2, and then 1. And all that is the square root of 1 over 2, but the square root of 1 is 1. The square root of 2, the square root of 3, and then this is the square root of 4 over 2. But the square root of 4 over 2 is just 1. And then we label those same tick marks going in every direction. And now you're going to be asked to do this without any notes and strictly from memory. So your life will be a lot easier if you can remember how to make this grid, or at the very least envision it in your head. And now as I go around, it's the unit circle, but it's really hard to draw the circle and make it look accurate. So I'm going to do more like tick marks at each spot that we're interested in. And this first one is 30. The next one's 45, the next one's 60, and then this one's 90. Kind of keep going around the circle doing that. So it's going to look more like a diamond, but we know it's supposed to be a circle, just really hard to draw it that way. So we get 210, 225, 240, 270, 300, 315, 330, and then this is 0, which is also 360. So if you're not done drawing that, you might want to pause the video, draw it out, and then start playing again when you're done, because you're going to want to have this in your notes somewhere. Alright, then what we're interested in is sine, cosine, tangent, and also secant, cosecant, and cotangent. We have to be able to do those things in degrees and in radians. So the first thing is that pi radians is equal to 180 degrees. So if I were to go all the way around this circle, the circumference would be 2 pi. 2 pi r, there's a radius of 1, so 2 pi. So if 2 pi is all the way around the circle, that means pi is halfway around the circle. So pi is 180 degrees. So from there, I can convert any radian measure to degrees, which we'll go through how to do that in a second. Next thing you want to be able to know is that cosine is the x value, sine is the y value. I just spell sine like that to help people remember that it's the y value. And tangent, you can think about it as y over x or sine over cos. So let's start looking at a couple problems with that. Actually, let's do this first. So we got those. We also need to know that secant is the reciprocal of cosine. And that's not any technical way to write it. It's just a way that helps people realize. If you flip over secant, you get cosine. If you flip over cosine, you get secant. And then if you flip over cosecant, you get sine. So it'd be nice if cosecant flipped over were cosine, because they both start with a C, and then secant and sine, because they both start with an S. But you got to remember it's backwards. So secant goes to cos, cosecant goes to sine, and then cotangent, this one's a little easier, is the reciprocal of tangent. So using that information, we can solve pretty much any problem anywhere on that circle that hits one of those dots. You're never going to have to do the cosine of 58 or something like that. It's going to be something that's on one of these dots. So let's say I wanted to find the cosine of 3 pi over 4. All right, the first thing I would do is get that into degrees, because the problems are going to be in radians, but we don't really think in radians, at least I don't. I think in degrees. So I need to realize that this is really the cosine of 3 times 180 over 4. And there's going to be a lot of times you have to do this without a calculator, so you need to be able to kind of give yourself easier ways to do it. So the hard way to do it would be go 3 times 180 and then divide it by 4, because you're making your numbers bigger. Let's make the numbers smaller. Let's do the 180 divided by 4 first. So 180 divided by 4. Well, 180 divided by 2 is 90. If we divide it by 2 again, we get 45. So this part here is 45. And then 3 times 45, you can multiply that out, or you can look at your little grid too. So there's 1 45, there's 2 45s, and there's 3 45. So this problem is really just the cosine of 135. So what we want is the x value at 135 degrees. So I'm going to find 135 degrees, and if I want cosine, I go down to the x-axis, and I'm going to read off that value. If I wanted sine, I would go to the y-axis, and I would read off that value. If I wanted tangent, I would do the y value divided by the x value. But right here I want cosine, so I'm just going straight down to the x-axis. That is 2 tick marks to the left, because we've gone to the left twice on our little grid. And the cosine there is negative square root of 2 over 2. And that's your answer, and that's what you'd be expected to tell me. Let's say sine of 5 pi over 6. All right, so kind of think through the same process here. And if you want to pause the video, try this on your own, and then restart it to make sure that, that you did it right. That's probably a good idea. If you're not quite ready to do that yet, then just keep watching. So sine of 5 pi over 6. So I'm going to think about that as sine of 5 times 180 over 6. And again, if I try to do 5 times 180, that's a big number. I don't really want to think about all that and then divide it by 6. It's much easier, for me at least, to do 180 divided by 6, which is 30. And then do 5 times 30. So that's sine of 150, which means we want the y value at 150 degrees. So I find 150 degrees on my grid, and I read over to the y value. So if I go straight across, the y value is 1/2. That's because it's the first degree, or first tick mark up from the axis. If I just go straight across there, that gives me a value of 1/2. And this way you don't have to remember which quadrants sine is positive in, and cosine is positive in, and tan is positive. You're just looking at the y and the x values, and if they're positive or negative, then that's what you go with. All right, let's say we had to do cosecant of, let's say 3 pi. So a couple things here. First of all, 3 pi is not on my circle. So this is really cosecant of 3 times 180, which is really cosecant of 540. But 540 is not on my circle, so it's too big. So I'm going to subtract 1 revolution of the circle to get back to a place where I'm actually on my circle. So if I subtract 360 here, this is really cosecant of 180. And we know that cosecant is sine flipped over. So I'm going to find the sine of 180 and then just do the reciprocal. So the sine is the y value. So I find 180 degrees. And I want the y value. So how far up or down has that gone? Well, the y value here, if I read over to the y-axis, is 0. So the sine right there is 0. I want the reciprocal of that. So the reciprocal of 0 would put 0 on the bottom. And then we're dividing by 0. And we are not allowed to divide by 0. So what you get here is undefined. You have a 0 on the bottom, and we can't divide by 0. All right, let's say cotangent of 5 pi over 6. Well, let's do 10 pi, 5 pi over 3. 5 pi over 3. So again, we're thinking about that as cotan of 5 times 180 divided by 3. So I'm going to take the 180 divided by 3, because that part's easier to work with first. So 180 divided by 3 is 60. 5 times 60, so I really want the cotan of 300 degrees. Cotan is tan flipped over. So cotan is really x over y, or cosine over sine. So I need to find the cosine at 300 and divide it by the sine at 300. So I'm going to find 300. Cosine is your x value. And line these up very well. This should be more kind of over there. So it should line up with that. So cosine of 300, if I go up, that's only one mark to the right. That's only one dot to the right, so one tick mark to the right. So the cosine there is a half. I'm going to divide that by the sine of 300. Well, the sine of 300 is the y value. So I go over to the y-axis, and that is the negative square root of 3 over 2. So now this gets a little goofy. We don't divide fractions. We invert and multiply. So we invert the thing on the bottom. So this would become 1/2 times negative 2 over the square root of 3. If I multiply those across, I'm going to get a negative 2 on top and 2 times the square root of 3 on the bottom. To me, that's an acceptable answer. To the AP test, that's an acceptable answer. You do not need to rationalize the denominator. And what that means is to get rid of the square root on the bottom. However, they might do it on the AP. Like on a free response, you're good. Stop. On a multiple choice, they might have rationalized, and they might not have. So you need to be able to understand if your 5 answers are all rationalized, which one matches up with this. So what we're going to do, first of all, I'm just going to cancel out those 2's. That'll leave me there. And then I'm going to multiply the bottom by the square root of 3, because that, when I multiply those 2 square roots together, I'll just get 3, and I'll have no more square root in my denominator. But whatever I do to the bottom of the fraction, I got to be fair and do it to the top. So when I multiply the top, I get negative square root of 3. This is my answer. This is an acceptable answer. This was an acceptable answer. All of them are fine. If it's a short answer, you can put any of them. If it's a multiple choice, you would need to be able to recognize that those are actually all the same thing. All right, I'm going to do a couple more here. And again, if you want to pause the video after I put the question up, try it yourself and then replay the video. I think that's probably a good idea. I'll just go through 2 more, and then I'll put an assignment with it, and you can practice those on your own. So let's say I wanted the sine of 7 pi over 2. So that is the sine of 7 times 360 over 2. I'm not going to really figure out, I don't care what 7 times 360 is. I'm going to do it a little different. So that's too big for me to kind of work with it easily in my head. So I'm going to do 7. So 360 divided by 2 gives me 180. So I have sine of 7 times 180. Well, 180 is halfway around the circle. So we're going to go around the circle 7 times. So if I go back to my circle, that's 180. That's 2 180s. That's 3 times, 4 times, 5 times, 6 times, and 7 times. So the sine of 7 times 180 is the exact same as the sine of 180. And that is just the y value at 180, which I think we've done this one already, is 0. All right, so let's say I wanted the secant of 315. Sometimes they'll give it to you in degrees. Not very often, but they could. Secant 315. So secant, we got to remember, is cosine flipped over. So I'm really looking for the cosine of 315, and then I'm just going to flip it upside down. So 315 degrees is here. I'm interested in the cosine, and then I'm going to flip it. But cosine's x value, so I'm going to go up to the x-axis. That gives me the square root of 2 over 2, but I need to flip that because secant. So that's going to be 2 over the square root of 2. And now, again, that is an acceptable answer. On a short answer, on a free response, on my test, you can leave it that way. If it's multiple choice and they rationalized it, you also want to be able to understand what they did. So, again, I'm going to multiply by the square root on the bottom because the square root of 2 times the square root of 2 is just 2. But then I have to do it on top also. So whatever I multiplied by here, I have to do here. So then that gives me 2 times the square root of 2, which is also an acceptable answer. But really, you could cancel those out and just get the square root of 2. So any of those three are really the same thing. All right, so I'm going to stop here. There is an assignment on Schoology that is connected to this. I'd like you to try that and bring in questions tomorrow.